September 27, 1940. The British Merchant Shipbuilding Mission Headquarters, Washington, D.C. Rain drummed against the windows of the temporary offices as Admiral Sir Cyril Gordon Fuller reviewed the latest casualty reports from the Atlantic. Another 14 merchant vessels lost to U-boats in a single week. The mathematics were brutal and undeniable. Britain was losing ships faster than its centuries-old shipyards could replace them. What Admiral Fuller didn't know as he drafted his desperate request to American shipbuilders was that the solution would come not from naval architects, but from a dam builder who had never built a ship in his life. Henry J. Kaiser had made his fortune pouring concrete. The man who had helped build the Hoover Dam, the Bonneville Dam, and the Grand Coulee Dam understood one thing better than anyone in America: mass production. When the British Purchasing Commission approached American shipyards with an emergency order for 60 cargo vessels, Kaiser saw the specifications and made a proposal that caused actual laughter in the smoke-filled rooms of the Maritime Commission. Ships in 90 days? Captain Edward Macaulay of the Maritime Commission later recalled the meeting. "We told Mr. Kaiser that a properly built merchant vessel required 355 days from keel laying to delivery. That was the standard. That was how it had always been done." Macaulay paused in his testimony. Mr. Kaiser asked why. "We didn't have a good answer." The ship in question was designated the EC-2 SC-1, emergency cargo, second design, steam engine, C-1 hull type. The specifications were deliberately simple: 441 feet 6 inches in length, 56 feet 10.75 inches in beam, 37 feet 4 inches depth, 10,500 deadweight tons. It was designed to carry 2,840 tons of cargo at 11 knots. Naval architects had stripped away every refinement, every luxury, every feature that wasn't absolutely essential. "She's an ugly duckling," one British naval officer commented upon reviewing the plans. What he meant was clear: this was a ship beneath contempt, a floating warehouse that real sailors would never respect. The traditional shipbuilding process was exactly that: traditional. It had evolved over centuries. You laid a keel. You built frames. You attached hull plates with rivets. Millions of rivets, each one heated, inserted, and hammered by skilled teams. The USS Arizona, built just 24 years earlier, had required over 7 million rivets. A Liberty ship would need approximately 2 million if built the conventional way. At Todd Shipyards in Brooklyn, master riveters worked in 4-man teams: a heater, a catcher, a bucker, and a riveter. These teams could place perhaps 400 rivets in a 10-hour shift. The arithmetic was simple. Traditional methods meant traditional timelines. Kaiser's proposal involved something the old guard considered dangerous, unreliable, and fundamentally unnautical: welding. Instead of rivets, he wanted to use electric arc welding to join prefabricated sections. Commander, later Admiral Edward L. Cochrane of the Maritime Commission's Technical Division reviewed Kaiser's initial proposals with barely concealed disdain. "Welding creates points of stress concentration," his technical report stated. "Prefabrication prevents proper alignment. The proposed timeline disregards fundamental principles of naval architecture." The skepticism ran deeper than technical concerns. Kaiser wasn't part of the club. He didn't come from the shipbuilding families of Bath, Maine, or Newport News, Virginia. He hadn't apprenticed in British yards. He didn't understand that ships were different, special, almost sacred. You couldn't mass-produce a vessel that would face North Atlantic storms the way you mass-produced automobiles. November 1940. Richmond, California. Kaiser broke ground on Shipyard No. 1 while traditional yards were still debating his contracts. The site was a mudflat on San Francisco Bay. There were no dry docks, no skilled shipwrights, no infrastructure. Admiral Land of the Maritime Commission visited during construction and wrote in his diary, "Watched Kaiser's people pouring concrete. They're building a shipyard like they're building a dam. This will be educational, if nothing else." What Kaiser proposed to build at Richmond, and at 6 other yards he would eventually operate, was revolutionary in its simplicity. Instead of building a ship from the bottom up, piece by piece, he would build it in sections. Large sections. Massive prefabricated assemblies that could be constructed simultaneously in different parts of the yard, then lifted into place and welded together. The impossible hull jig was the key. Traditional shipbuilding used the keel as the reference for everything. Kaiser system used massive steel templates, jigs, that held prefabricated sections in perfect alignment during welding. These jigs weighed 35 tons each and were precision machined to tolerances of 1/16 of an inch over their entire 50-foot length. "It's backwards," declared James Cadell, president of the Pacific Coast Shipbuilders Association. "You can't build the parts before you build the ship. The ship is the reference. This is putting the cart before the horse." The technical specifications of Kaiser's prefabrication system seemed to violate everything traditional shipbuilders knew. Hull sections would be built as complete assemblies, some weighing over 70 tons, measuring up to 50 feet long and containing entire cargo holds complete with internal framing, decking, and sometimes even piping. These would be built at ground level, where welders could work comfortably, then hoisted into position by massive cranes, another Kaiser innovation, as traditional yards relied primarily on human labor and simple hoists. "Steel doesn't remember its position," argued Master Shipwright Thomas Mackenzie in testimony before the House Merchant Marine Committee in December 1940. "When you cut it, move it, weld it, the stresses change. These large sections will warp. They won't fit together. And even if by some miracle they do fit, the welds will crack. The first storm will find every weakness." The proposed timeline seemed equally fantastical. Kaiser projected 150 days for the first ship, with rapid improvement thereafter. His ultimate goal, stated publicly, to the amusement of experienced builders, was 60 days per vessel. The venerable Bethlehem Steel Corporation, which had been building ships since 1905, required 210 days for a comparable vessel and considered that exceptionally fast. Admiral Emeryland, chairman of the Maritime Commission, approved Kaiser's contracts not because he believed they would succeed, but because Britain was desperate. "We gave Mr. Kaiser permission to try," Land later testified. "I didn't expect him to revolutionize anything. I expected him to learn, the expensive way, why shipbuilding takes time." Land paused. "I expected him to fail respectfully, and then we would bring in the real shipbuilders to finish the job." April 14, 1941. Richmond Shipyard No. 1, California. The keel was laid for hull No. 440, the first Liberty ship to be built on the West Coast. Photographers recorded the ceremony. Maritime Commission observers took notes. Traditional shipbuilders watched with the patient superiority of experts waiting to say, "I told you so." The ship would be named SS Patrick Henry, after the revolutionary who had declared, "Give me liberty or give me death," a choice that would give the entire class its eventual name. In the vast prefabrication sheds that Kaiser had built around the slipway, something unprecedented was happening. While the keel was being laid, other parts of the ship were already being built. Deck sections were being welded. Engine bed plates were being assembled. Bulkheads were taking shape. It was simultaneous construction, and it violated every instinct trained into traditional shipbuilders. What none of the observers quite understood yet was that Kaiser wasn't building a ship. He was building a system. The hull jig wasn't just a tool. It was a revolution in how humans could think about large-scale construction. And in 134 days, when SS Patrick Henry slid into San Francisco Bay, the revolution would begin. But first, there would be failures. There would be cracks. There would be moments when the old guard seemed absolutely, catastrophically right. September 27, 1941. SS Patrick Henry Delivery Day. The ship was late, 134 days instead of the projected 150 days, which Kaiser insisted meant they were ahead of schedule, a piece of logic that baffled traditional thinkers. But she floated. The welds held. President Franklin D. Roosevelt sent a telegram of congratulation. Admiral Land, present for the commissioning, gave a speech praising American industrial capability while privately noting in his diary, "One ship proves nothing. Let's see if they can do it again. Let's see if she survives the Atlantic." What happened next surprised everyone, including Kaiser. SS Patrick Henry didn't just survive the Atlantic. Over the next 4 years, she would complete 7 Atlantic crossings, survive a torpedo hit that blew a 30-foot hole in her No. 2 hold, and remain in service until 1958. The welded hull, which experts predicted would crack, proved more resilient than riveted construction. When the torpedo exploded, the damage remained localized instead of spreading along rivet lines. "She should have gone down," her captain, James Reardon, reported. "The blast would have popped rivets for 50 feet in every direction. The welds contained it." But one ship wasn't enough to change minds. "Luck," declared the established shipbuilders. "Wait until winter storms. Wait until metal fatigue. Wait until the welds fail." They didn't have to wait long, because the welds did fail, spectacularly and terrifyingly. December 1941 to March 1942. The cracking epidemic. SS John P. Gaines suffered a catastrophic deck crack in heavy seas, splitting nearly the entire length of her weather deck. SS William J. Palmer developed cracks around her midship hatches. SS Robert F. Hoke reported structural failures in frigid North Atlantic waters. The Maritime Commission convened an emergency technical board. Commander Cochrane's report was damning. The welding process, as currently implemented, produces brittle zones around weld joints. Under stress, and particularly in cold water, these zones fracture. We are observing crack propagation that would not occur in riveted construction. Our concerns have been validated. The technical problem was real and deadly. Electric arc welding, performed rapidly by semi-skilled workers, was creating heat-affected zones in the steel. The rapid heating and cooling altered the steel's crystalline structure, making it brittle. In water temperatures below 40 degrees Fahrenheit, these zones could fail catastrophically. 3 Liberty ships broke completely in half. 13 more suffered major structural cracks requiring emergency repairs at sea. "This is exactly what we predicted," declared representatives from traditional yards. James Cadell of the Pacific Coast Shipbuilders Association testified before Congress. The Liberty ship program should be suspended immediately. "These vessels are death traps. We should return to proven methods, riveted construction by skilled craftsmen following time-tested." Procedures. What Cadell and the other critics didn't know, what Kaiser's engineers were discovering in round-the-clock metallurgical testing, was that the problem wasn't welding itself. The problem was how they were welding, where they were welding, and what they were welding. March 1942. Richmond Shipyard No. 2, Engineering Lab. Dr. Constance Tipper, a British metallurgist on loan to the Maritime Commission, identified the primary failure mode: notch sensitivity in the steel combined with residual stresses from welding. But she also noted something that the critics had missed. "The failures are concentrated in specific areas," her report noted. "Square hatches create stress concentrations. Abrupt changes in plate thickness create stress risers. The welds themselves are sound, it's the design that's flawed." The solution came fast because Kaiser's system allowed for rapid iteration. Retrofit orders went out to all Liberty shipyards within weeks. Round the hatch corners. Add crack arresters, steel straps riveted, ironically, across potential crack paths. Change the steel specification to a lower carbon content that was less brittle. Modify welding procedures to include stress relief preheating. But the more revolutionary change was harder to see. Kaiser's engineers redesigned the construction sequence itself, changing which sections were welded when, and in what order, to minimize residual stresses. The hull jig system allowed them to control stress accumulation in ways that traditional sequential construction never could. April 1942. First ship with all modifications, SS George Hawley. She was built in 82 days. Maritime Commission inspectors examined every weld, every joint, every stress point. They sent her into the North Atlantic in the middle of storm season. She encountered 40-foot seas and survived without a single crack. Admiral Land's diary entry. Apparently Kaiser's people can learn. The question now is, can they scale? The answer was already emerging in the production numbers. Richmond Shipyard No. 1 had delivered 1 ship in September 1941. In October, 1 ship. In November, 1 ship. In December, 2 ships. But the curve wasn't linear. It was exponential. Each ship was a learning experience. Each welding team got faster. Each crane operator got more precise. Each prefabrication crew developed better techniques. June 1942. The system reveals itself. SS Stephen Hopkins slid down the ways at Kaiser's Richmond shipyard after 64 days of construction. That same day, Richmond delivered 2 other vessels. The yard that critics said couldn't build 1 ship properly was now delivering 3 ships simultaneously. How was this possible? The secret was the hull jig system working exactly as Kaiser had envisioned. At any given time, Richmond had 14 ships in various stages of construction across its 7 slipways. But more importantly, it had 43 ships being built in the pre-fabrication sheds. Deck sections for ships that wouldn't be keeled for another month were already being welded. Engine rooms were being assembled as complete units. Entire cargo holds, measuring 30 feet by 40 feet, were being built on the ground, inspected, pressure-tested, and then simply lifted into place. "It's not shipbuilding," observed British naval architect J. L. Robinson during a Maritime Commission inspection tour. "It's not traditional construction at all." He paused, watching a 60-ton midship section being lifted by one of Kaiser's massive hammerhead cranes. "It's assembly. They're building ships the way Ford builds automobiles. Good God, it's actually working." The welding crews were the key. Kaiser had taken teenagers, farmers, women who had never seen a shipyard, and trained them in welding in 6 weeks. Traditional shipbuilders claimed this was impossible. Welding required years of experience. But Kaiser's system didn't require welders who could handle any situation. It required welders who could do one thing perfectly: weld a vertical seam using a specific electrode at a specific amperage for a specific joint type. By breaking the job into specialized tasks, he could train specialists rapidly. Josephine Baker, age 19, a former grocery clerk from Oakland, later recalled, "They taught me how to run a vertical bead on 5/8-inch plate using a 5/32 inch electrode at 140 amps. That's all I did for 6 months. 8 hours a day, I welded vertical seams on bulkhead sections. I got really good at that one thing. When they tested my welds, the steel broke before the weld did." By mid-1942, Kaiser operated 6 shipyards employing 200,000 workers. Richmond Shipyards No. 1, 2, and 3. Swan Island in Portland. Oregon Shipbuilding Corporation in Portland. Permanente Metals in Richmond. Each yard was delivering ships on an accelerating schedule. The average time from keel to delivery dropped from 244 days in 1941 to 105 days by mid-1942. But something else was happening, something the critics hadn't anticipated. The Liberty ships were proving themselves not just seaworthy, but superior in several unexpected ways. When SS Stephen Hopkins encountered the German Commerce Raider steer in the South Atlantic, she fought back. Though outgunned and ultimately sunk, Hopkins's crew kept firing until they dealt enough damage to sink Steer, the only Allied merchant vessel ever to sink a German surface warship. The welded hull absorbed extraordinary punishment. "She held together," testified Ensign Kenneth Willett, one of the survivors. "We took direct hits from 6-inch guns that should have torn a merchant ship apart. The welds flexed but didn't fail. That gave us time to fight back. The narrative was shifting. What had been Kaiser's folly was becoming Kaiser's miracle. But the establishment remained skeptical. Acceptable production, they admitted, but not revolutionary, not truly exceptional. They hadn't seen anything yet.